Thanks, Kelly. And you pronounced everything perfectly. It's awesome. Thanks for having me, everybody. My name is Giovanni Rapacciuolo. As Kelly was saying, I work basically independently these days. I started my own little biodiversity data science shop. So if you have any needs, come and get in touch with me. I'll be talking today about a project that we've been working on with the Point Conception Institute. Relatively small project, but I think mighty and very, very important. So first of all, I just want to clarify what I mean by macroecology. And macroecology and macroecological tools are really refer to the identification of patterns and processes, ecological patterns and processes that are large across large scales in one of at least these 3 dimensions. So they're either large in space and or temporally and or taxonomically. So actually a lot of what we talked about today qualifies as macroecology based on this definition at least. Why might that be important to support decisions at the local scale? Well, because increasing our understanding of the macroecological context and where a particular place sits can actually help us reduce the uncertainty in some decisions that we might make. So I like to show this little toy example of us trying to predict the future distribution of a species, like as Amy talked about, and based on just a static data set of its current distribution, we might get an uncertainty of whether it could lead to an expansion or a contraction based on different climate projections, for instance. But knowing what has happened over the last period and that this is actually much more likely to be a continuing contraction, for example. So looking over time and over space at a macroecological level is going to help us out make good decisions. So this project was really about trying to understand the macroecological context of the Dangerman Preserve. Where does it sit currently and where has it been across spatial, temporal, and taxonomic scales? This really started with basically a mini review of evidence and trying to understand where the meaning of this area from a biogeographic and macroecological context. So a lot of this might be things that you already know, but I just wanted to give us the right background. So for a long time, point conception has been thought of as a biogeographic barrier, certainly in the marine realm, and for very good reason, because as we've started talking about, point conception is a site of a sharp change in oceanographic parameters with, to the north, higher upwelling and colder temperature waters, and to the south, weaker upwelling and warmer waters. And so that it's been long thought of as the break between the Oregonian province biogeographic province and the Californian biogeographic province. More recently, there's been a good amount of evidence to support this, including from the Marine Biological Survey data that we just heard about from Erica, as well as a bunch of other studies. But when you really sum everything up in the marine realm, the evidence to point conception being a firm barrier to the movement of genes and individuals is actually quite mixed. And there's evidence on both sides. What seems to be quite clear is that it's best thought of as a transition zone. So part of a broader transition zone that includes Santa Monica as well, where species of both northern origin and southern origin actually meet. So this is just evidence from fish, for example, that shows that at 30 degrees latitude, which is the latitude approximately of the Dangerman Preserve, we have equal amounts of northern origin and southern origin species, and there's a transition between those to the north and the south. What's quite interesting as well from some of this more recent research, this paper here is about fish, is that there seems to be a slight difference in the permeability of this transition zone, if you will, between species moving from the south and species moving to the north. That is that actually there's a good amount of southward migration, at least in the marine realm, but not as much northward migration. So it seems to be a much more firm barrier to the northward movement in the ocean. And that clearly can be a problem under climate change if subtropical species aren't able to move northward. So what's going on land? The marine picture is a lot clearer than the terrestrial picture around this area. So we wanted to figure out a little bit more about the macroecological context on land as well. And you probably know about this paper from Kling et al. That ran a bunch of species distribution models up to 3,000 for plants and derived a number of biodiversity patterns, including this one for unprotected intactness that sort of highlights point conception as a very important area to be protected. I believe this was one of the pieces of evidence that led Jack Dangermond to decide to actually purchase the land there. Or, yeah, possibly. And so what we actually did as part of this project is a reanalysis of some of those data. And so just to illustrate what we did here was to try and identify the probability of southern and northern limits for these species. So this is essentially a species distribution model. So it's a probability surface, but it's been turned into the probability of a latitudinal limit. So this is the southernmost 10% area for the species. And I've summed up here the probabilities of presence across latitude for the species. So actually you see that in the blues here are the highest probability latitudinally that is the southernmost limit for the species, right? So in the blue here is the higher likelihood of the actual limit of the species based on the model probability of it. So what happens is if you if you stack these across all 3,000 species, you get basically a cumulative probability of the accumulation of range limits. In this case, northern range limits doesn't appear to be a whole lot going on in the point conception area, but actually a lot more towards the Monterey area for the accumulation of northern range limit of plant species. This is. But what's interesting is actually there seems to be a higher accumulation of southern range limits around the point conception latitude, which actually is opposed to what I was just talking about in the marine realm, which is, I think, is particularly interesting because in the marine realm, we had a higher accumulation of northern range limits with a harder barrier to the movement northward, while it seems to be that there could be an opposing pattern with plants, although it's important to note that for plants, I'm showing you the latitude here, the actual barrier is likely to be the transverse ranges, which are a lot more internal here. They don't have anything to do with the ocean anymore. And so the transverse ranges seem to be a stronger barrier to the southward movement of plant species. Another thing we did as part of this project was to gather and integrate a bunch of species occurrence data to try and basically build some of these patterns and update some of these patterns live based on data coming in. So we integrated a bunch of data sources, which we already talked about, Amy already touched on as well. And basically, I just helped the team build a little tool here, which you can go and visit. And part of this was that we wanted to put the Dangermond Preserve in its broader context. And so actually these data have been integrated across Santa Barbara County, essentially. And they show, it's a species occurrence database that you can explore in its taxonomic resolution, temporal resolution, and spatial resolution. And then, go visit the underlying data. Obviously, this is only the first step towards actually building some of that understanding of some of those patterns that I was showing from static data sets, building those in a dynamic way that can be updated as new data come in. And one of the key things that we have to do, and we can do based on these species occurrence data, is try and understand over both space and time how well some of these areas are being observed, right? So there's only one way to go back to the early 20th century to understand trends to potentially improve our forecasts, and that's to look at what's sitting in our museum collections, the long-term surveys that are being conducted around the area. So this database allows us to look for that. Am I running out of time? Oh, you're the timekeeper. Sorry, I was looking at that's why. Okay, great. So these are some of the patterns that we can start putting together to basically understand what might be going on in the precise area that we care about. So let's say we care about the Endangerment Preserve and management on the preserve. That doesn't mean that we are limited to exploring data on the preserve, because there's actually a lot of areas surrounding the preserve, including, for example, Sedgwick Reserve, which will be deeply informative towards the Endangerment Preserve. So understanding what is going on in the broader region and similar potentially connected habitats is very important. But clearly we have to understand how good the sampling at some of these places has been over years. So these are just some of the patterns that we can look at. Obviously, the number of occurrences that we have in different areas. And you can see that, for example, just to the north of the Endangerment Preserve, there seems to be areas of very high intensity sampling, probably the Vandenberg DOD site. And, you know, we can start looking at things like the number of years that a place has been sampled, the number of independent visits from different folks, as well as the proportion of taxa in the overall area that have been sampled in a given place. Why is this useful? Well, if we start understanding how hard people have looked through decades, we can start making a little bit more sense as to the temporal trends that we're now seeing, thank you, in the data. So this is just an example, and this is preliminary data just for the purpose of explanation here of where we're trying to go here. But if we think about the Gaviota tar plant and pretty much anything that you might be thinking of looking at long-term data, because of the explosion of community science recently, things like iNaturalist and so on, there's a ton more data in recent years, especially in places like Dangerman, which, you know, have been private and closed off to the public, still are closed off to the public, but not everybody. Then there's an explosion in recent years. Clearly, this doesn't mean that there has actually been an explosion in the population of a given species, because if you look at records of the entire class of flowering plants, clearly the pattern is the same across all plants. What's interesting, though, is that basically, if you take into account the overall pattern of flowering plants and put the species that we're interested in from a conservation perspective in the context of the entire class, then we can start seeing that actually proportionally, even though we're looking harder, the records of the Gaviota tar plant are becoming more and more difficult to come by. And I'll just finish with, once again, this also takes us to potentially more certain or less uncertain, I should say, forecasts of species range shifts. This is just an example here with the purple sea urchin in this area, work with the California Academy of Sciences and the Ocean Protection Council. And I'll just wrap it up here. Just say, once again, thank you so much for having me. And please feel free to get in touch so I can go into a little bit more depth into some of these things. Thank you.